Okay, so here's a good example for us to work out. We're saying that an electrorefining cell produces copper from copper 2 ions. What we're going to do is determine the mass of copper deposited at the cathode if the cell operates at 9 amps for a full hour. Alright, so this is going to involve everything from this unit, from half reactions to this cell stoich we've just been looking at. Let's first determine how many moles of electrons will be transferred at 9 amps for an hour. Alright, we can find the total charge. Remember, that's just the current multiplied by the time. Alright, the current's 9 amps. The time is 1 hour, but that's no good. We need to put this into seconds. Okay, so 1 hour is 60 minutes, and then there are 60 seconds in a minute, so that's going to be 3,600 seconds. Okay, so that's going to give me 3.24 times 10 to the 4 amps. We want to know, pardon me, that's coulombs. I'm going to leave that in there. Everyone makes mistakes. We want to know how many moles of electrons that's going to be. Okay, and that's just the charge divided by Coulomb's constant. You could do all this at once. You could say N equals IT over F, but I'm going to do it this way. Okay, so I'm taking the total charge, dividing by Faraday's constant. Okay, I get 0.336 moles of electrons. Okay, that's going to tell us how many moles of copper are produced, because we know that the half reaction for producing copper looks like this. Okay, so now we apply the molar ratio. There's 1 mole of copper produced for every 2 moles of electrons. Alright, so the number of copper moles is going to be the number of electron moles, and then the language we used back before the pandemic took away class was multiply that by desired over given. Alright, we're looking for copper, that's our desired. Its coefficient is 1. The given number of moles is electrons, its coefficient is 2. So this is going to tell us how many moles of copper are produced. I get 0.168. So that's the number of moles of copper. The question asks, what's the mass of copper? So there's one more step left. Okay, you're going to need your data booklet. You're going to need to find the molar mass of copper, which is not going to be a big deal at all. Okay, it's number 29 right here. Okay, so 63.55 grams per mole. So let's say the mass of copper here is going to be the number of moles times the molar mass. So that's going to be 0.168 times 63.55. Let's see what we get. 10.7 grams. All right, I just want to go over all those steps one more time so you know what's going on. First, we found the total charge transferred by this circuit, or by this cell. 9 amps, which is a lot of current, but it's certainly obtainable, for a full hour, transfers this many coulombs. Alright, coulombs is just total charge. Faraday tells us that every mole of electrons has this much charge. Again, what we did is coulombs divided by coulombs per mole of electrons. That gives us moles of electrons. Okay, then we applied the molar ratio. In this half reaction, this is the half reaction responsible for copper being formed at the cathode. The number of moles of electrons transferred multiplied by that molar ratio tells us the number of moles of copper produced. And then it's just simple stoich. Number of moles times molar mass gives you the mass. Okay, so this cell operating for an hour is going to produce just about 11 grams of copper.